Hello, and welcome to this presentation on building wireless launch systems for rocket clubs. My name is Rick Boyette. I've been building wireless launch systems for our club for several years. In this video, I'll discuss how to build one that can be used by itself or as part of a multi-pad, multi-cell setup. So the topics we'll be covering include adapting the commercial modular fireworks systems into a model rocket launch system, building the wireless relay launch system, component sources, troubleshooting common problems, and then a question and comment period. So to adapt a commercial modular fireworks system, I use a DBR system, which is a low-priced wireless fireworks system. It's got about a 600-foot range. You can control up to 1,200 pads total, which is a lot more than anybody here would ever need, but it's nice to have that capability. Transmitter uses 6 AA batteries, provides a 2-second pulse to the low wattage receiver, and you cannot adjust that pulse duration. The receiver modules are easily paired with a transmitter, so you can add on as many modules as you want to expand your range setup. The receiver is used to trigger a standard relay board, non-programmable one, that provides 12 volts of power to the igniter leads for the duration of that pulse. The reason we do that is the modules are low wattage and they don't put out enough power to reliably fire igniters on their own. They're designed for use with electric matches used in fireworks systems. So to provide a pulse of a longer duration, we can use a receiver to trigger a timer relay module. FSA uses 4 different boxes right now. For low power, we have 2 6-pad racks. Each one has a 6-channel receiver and non-programmable standard relay modules that would show up on our launch controller as District 01. And mid and high power pads, we've got one 12-pad box with a receiver, and that services individual pads. Again, those are non-programmable modules. High power box, the District 03, you got one 4-pad box that uses programmable electromechanical relay modules. Then high power wave cell, that is a 4-pad box, and it uses the programmable solid state relay modules. And that's the one I will be going in detail on how to build. All the boxes are operated from the single controller. And again, it has about 600-foot range line of sight, which is more than enough for just about any application up to M power. So we have the low power racks, the gray boxes that you see on the sawhorses. That contains the relay modules and the battery and the relay boards, or the continuity. Those are the continuity buttons. All that other materials and components are inside the box here. Fast and easy setup. We don't have to drag a bunch of cables around. Basically, just turn them on and make sure they're operating, and we're ready for a day's launch. Main thing we check is batteries being charged up and that the clips are clean. So we'll do a continuity check, and then we're ready to go. And on the mid power, this is a typical range. We have the box located in the center with the leads radiating out to the different pads. So you can see the boxes right there. Everything is in that one box. The receiver, the relay boards. And it has an external or an internal battery. This shows the internal arrangement of the utility box. We've got a relay module right here, and we have the receivers right here. Normally that's inside the box. I just pulled it out so you can see it in the battery. And that's for continuity. See a bit of a rat's nest of wiring here. This is the controller 12 buttons for individual pads, and then this little thing here is used to select the cell, the district. So this would be our mid-power setup. These are the digital electromechanical relays, single channel boards. And this is the receiver, and the battery is in there inside the box. So these are programmed for 5 seconds. Same with the other box, got a continuity check and plug in the leads right there. So this shows basic wiring diagram for a standard relay single pad box. Would have an individual receiver, and then you have the relay module, voltmeter showing power that's available, power switch obviously turns the box on and off. Continuity circuit is connected over to here through the normally closed relay. This power goes into the common output of the relay. And normally closed means that there's always power to it until you hit the relay, until you trigger the relay. So to check continuity, power goes through the buzzer, and then it goes through the igniter, back to the battery. Obviously, the igniter's burned out, circuit does not complete. The 12-volt buzzer drains enough power that tripping the continuity circuit does not send enough power to the igniter. That's very standard, just like you would in any other launch system. So these standard relays are fairly simple, inexpensive. This is a little bit different wiring diagram showing multiple receivers or multiple relay boards run off of one wireless receiver, as the channel 1 and channel 2, but basically it follows the same circuit path. And the igniter leads again, you can check continuity by coming off this feed here through the buzzer, push the button, checks continuity. This goes back to the battery negative. So everything here, DC negative 12 volt DC, that's all pigtailed back to the negative on the battery. There's no programming, you just plug things into the terminals and go. Again, fairly straightforward. Now this is a digital, basically the same thing. The only thing is you got to program the time for this. So this will be triggered. This connects to the receiver. The receiver triggers this board. We have a 10K receiver to drop the trigger voltage down below the threshold. Sometimes you don't need a receiver, sometimes a smaller receiver, or a resistor rather, and it really depends on the board, but you usually need some kind of a resistor in there. But again, it's basically the same circuit, and this goes to the igniter leads, normally open. When the relay trips, the circuit is closed, and that's sends power to the igniter, and that is the negative leads are all pigtailed back to the negative terminal of the battery. The input plus, that's the trigger. That comes from the receiver. Now, when we have the solid state type board, which is the one I'll be talking more about in depth, it's very similar, but these boards are not compatible with an integrated continuity circuit, so we just have to make the continuity circuit separate. You could do this on the other relay board as well. Basically what this does is keeps everything separate. The common button on the double pull, double throw push button, momentary switch, those are connected to the igniter. And then the normally closed terminals of the push button are connected to the timer board. And then the normally open, it would be this continuity circuit. Again, fairly straightforward, but this is a little more complicated. You got more wires to hook up here. So getting into actually building the system, we're just going to cover some basics, and depending upon which modules you use and which receivers you use, it'll be a little different layout, but it's all going to be the same functionally. A typical setup, you're going to have a DBR wireless controller. Again, you can see it's got the 12 individual pad buttons, and 0 to 99 is the districts. You can have a fire all circuit and a sequence circuit. We don't usually use those. Sometimes the receivers are actually locked out. You can't use it, but the Pyro Boom company that I bought these components from, you can request that that circuit be active. I don't really want to get into that right now. That's part of the operational. Then you've got a multi-pad launch box, which would basically be your relay boards and the standard utility box here with the continuity buttons. And there's 12-volt battery inside. You can set these up for internal or external, or using a double pole switch. It can be either one. The launch box can be anything you want, as long as it's durable. It can hold all the components. These inexpensive plastic toolboxes with the removable trays, they're well suited for adaptation. That's what I've been using for all the systems I've built. And then the electrical utility box is just attached to the outside of the launch box. So here's a typical launch box enclosure. This is the one I use for the box I'll be talking about today on how to build it. It's large enough to hold all the components needed. And then it's got a storage tray to put the leads and the test lamp and a buzzer and some spare batteries, whatever you want. You know, it's nice to be able to keep everything in one place. Costs $10 at Lowe's or Home Depot, so it's all cost efficient. If you're going to have more than 4 pads, I would go with a bigger box just so you have more room to work with. So here's the electrical components, electronic components. We got a 4-channel receiver. I got 4 timer modules. Here's the momentary double pole, double throw push button switch. You see it has the 6 terminals on there. And then you got hookup wire, 20 gauge solid, works well. Here's the 12 volt piezo buzzer. This actually works quite well with a 9 volt battery. And then a flush mount DC voltmeter. And the 10K resistors that these particular boards require. And toggle switch, that's for your power. And then the 15 amp fuse or circuit breaker, just to protect the system inside in case of a dead short. Hardware items also include the 2-gang outlet box and the cover, the standard household utility box there for household wiring. 9-volt battery holder, that's for the continuity circuit. Extension cords, I cut female plugs off, and then I use that for the igniter leads. The test leads, I cut them in half, and then I pigtail them onto the extension cord to make the igniter leads. Again, you want to observe polarity so that you don't connect things backwards. 18-inch length of LAN cable. That's to connect the receiver to the relay boards. These are the trigger signal wires. And the nice thing about LAN is they're either color coded, solid, and stripe. Makes it a lot easier to keep track of. And there's 8 conductors, which is perfect for a 4-channel receiver. And I have some hardboard. That's kind of what I'm going to use to build the shells to hold the components. And a wood dowel, square dowel. That's what's used to support the shells. And then we've got a duplex outlet. You need 2 of those, and you need to remember to break the tab off that connects the 2 outlets together. And just pop right off with a pair of needle nose. But if you forget to do it, then your pads are only going to work on one circuit. So don't forget to do that. Want some wire strippers, obviously. One thing about the LAN wiring, it seems to be a little hard to strip. So you kind of have to work out a little bit. So get a good pair of wire strippers. Small screwdrivers, wire connectors. These are called wire nuts or wire connectors, and the crimp terminals, and standard components, small screws, nuts, and washers. You can use wood screws. I use wood glue to glue the dowels to the hardboard, or you can always use screws. The Velcro squares, that's how I just attach the top component shelf to the lower support shelf, and drills and other tools typical for any kind of construction action here. So, okay, we're going to talk about assembling the interior components. So the hardboards are used as shelves. So you cut them to fit the toolbox. The support shelf goes on the bottom, and then you glue the 3 dowels, square dowels. You can do them this way, or that's the easy way to do it. Then it'll just sit nice and even on the bottom of the box. So when your box is in, or your support shelf is in place, you'll have a space for your 12-volt battery. Here's the terminal. I use a 7 amp hour standard 12-volt gel cell. And then on top would be these two dowels. That's what's going to hold up the component shelf. And this one is sized for that Husky 16-inch box. These little notches are just to fit around the moldings of the box. These X's are where we would drill holes for the machine screws to attach the bottom shelf to the box. I also recommend you drill a couple holes in the bottom of the box just to drain water out if it were to get wet. Well, here's what the support shelf looks like. These are the screws used to hold it to the box. They just come up through the bottom of the box. This would be the circuit breaker. I've since replaced that with a fuse. This wire is going to go to power the continuity circuit. It's just there. Well, I took the picture. And that's the bottom shelf. So the battery will fit right here. And then our top shelf is 3.5 inches shorter. That gives room for the battery. And then these dowels, you're going to place these square dowels to line up with the holes on the relays, because these are where the relays are going to be mounted. So whatever relay you're using, you just mount them on there so that the holes are kind of in the center. You cut a hole in the panel or the shelf for the voltmeter. You can use a scroll saw or whatever. That's really the only thing you have to use a scroll saw on. The rest of these are just drilled holes. That's for the power switch. This is a hole for the 9-volt battery. Just put the battery clip there and just run the wires down. We want to keep the wires tucked away, so that's why we have all these holes. So this is where the receiver is going to go. And you drill a 1/4-inch hole for the LAN cable. And then it comes up through these holes. Each individual one would come up through these holes to connect to the input side of the relays. And then the output side of the relays will go through these holes. The wires will go down through them, and then they'll go through the wall into the utility box, which would be over here. So again, the idea is to keep all the wires out of the way. Nice and neat. So you're going to secure this component shelf to the 2 bottom shelf dowels with the Velcro squares. You could use screws as well for that. I like the Velcro squares. That makes it easy to open it up if I need to. So here's what the component shelf looks like with the components in place. I put like 4 Velcro squares on the bottom of the receiver and just stuck it on there, because you have to be able to remove it to replace the batteries. Now these leads, these are the LAN cable leads. Those connect to the terminals on this box. What I found with these receivers is these things are mislabeled. The red is actually negative. The black is actually the positive side. When they're used for fireworks, it doesn't matter. You're just connecting an E-match directly to it. So you definitely check the polarity of the box, of the receiver, and observe proper polarity when you connect the trigger wires to the relays. And there's the power switch. And then this notch here is so you can access the terminals of the battery when you put the shelf in place. So here's a close-up of the relays. You'll see this here, that's the 10K resistor. Where it says SIGN, that's signal. That means that's positive signal. GND-T is the ground for the trigger. So that would go to the negative wire of the receiver, the terminal of the receiver, and then this wire. I got it soldered. The resistor, 10K resistor, is soldered onto the LAN wire, and then I got it covered up with a heat shrink tubing. So you can see the colors I labeled: the brown, solid and stripe colored for pad 1. So anyway, here's the wood block underneath, and then the screws. I just attached it with those screws. So here's how it looks labeled. Continuity circuit, trigger wires, trigger circuits. Again, I labeled the stripe ones I use on the negative and the solid colors I use on the positives. And then the boards are here, they're energized. So these are the output wires. The yellow ones are going to go to the double pole, double throw switch. These are the wires that come from the power, positive and negative. So here's what the underside of the component shelf looks like. There's the Velcro squares. And then this is the positive side. Positive wiring here. That's the power switch. This is the negative terminal. That goes back to the battery. This is the voltmeter. Everything else is going to be in the utility box. Here's the utility box. Drill some holes in the side through the back of the utility box, put up against the side of the black toolbox, and drill the holes to match, and then just secure it with a couple of screws. And then these holes are going to be used for the wiring, to pass the wiring from the component shelf. There's a round hole in the side of the utility box. That's going to be where the continuity buzzer is positioned to make it easier to hear. And these are the holes that you're going to drill on the top. I originally was going to use some bigger ones. That's why there's extra holes up there. I ended up using the smaller ones. Here's what the inside of the utility box is going to look like when it's completed. These are the double pole, double throw switches. There's the buzzer, not really easy to see it. And then these wires are connected to the normally closed terminals of the double pole, double throw buttons. But yeah, it's a little bit of a rat's nest of wiring in there. That's the trickiest part, just getting all the wires in there and making sure you got proper connections. Speaking of tricky parts, these little relays, or sorry, the double pole, double throw switches, they have 6 terminals, as I said earlier. This is how you would connect each wire to it. And then just follow this diagram. The switches are labeled. There's a little label on the terminals telling you which one is common, which one's normally open, which one's normally closed, and they're in pairs. So just kind of keep them all lined up, positive on one side, negative on the other. All the other connections you can use with wire nuts or screw terminals. Well, that's what it looks like once it's put together. You can see the little notch I cut out in the board. That's for the terminals, so you can make sure visually verify that the battery is connected. Disconnect the battery, you have to lift the shelf out. Usually you can just actually lift the battery out and it'll get disconnected on the lower terminal, and that's the negative, is below the level of the box. So you have to be careful when you put the shelf in that the battery stays connected. So you can see all the wiring here. This is all tucked away underneath the shelf. goes into the box. So now I'll talk a little bit about programming the timer modules.
This video I will show how to set up this display so that it stays on. Right now it's in sleep mode. We'll unplug the power. We'll plug it back in. Screen powers up, goes to 000, then it goes blank. So what we're going to do is we're going to hit the stop button. It says off. We don't want that. That turns the board off. Okay, we'll press it again. Now it's on. Okay, that means when it activates, power will go to the circuit. So we're going to press and hold the stop button. 0/D appears. That is the mode that we want. That means the display will be on. If we hold it down again, C/L, C-L means that the display will go into sleep mode. So again, hold the stop button down until that appears. So now that we've done that, we can program the timer for whatever time we want. So when we see it in the 000 mode, we got to enter the programming mode. So we will hold the set button down. There's a set button, a plus and a minus. Plus and minus buttons, the ones on the right, adjust the time. The set button gets us into programming mode, so we're going to set that until P1.1 appears, and then we're going to press set again, and you'll see OP appear, and then the program time will appear. So let's press it again, OP. Now I can adjust the time. It's going to show 2.6 seconds. Let's go 5 seconds. So we're hitting the up button. If you hold it down, it'll go really fast, so I don't want to do that. 5, 6, 7, 8, 9, 0. Now we got a 5 second. Now we'll hit set. And now we're done. Okay. So when I hit the launch button, which is set up for pad 1, district 1, pad 1, this would be the first pad on the first district, which would be like a bank of pads. So this is the receiver. Wireless receiver is linked to this. The receiver wires go into the input terminals. Kind of hard to read it. It says sign. That's signal, positive and negative. So when I hit this launch button, we should see a countdown and the little light should come on in 3, 2, 1. And now you see it counting down. Shuts off. So again, that's what you're seeing. That's dumping 12 volts into the igniter circuit.
Now we'll demonstrate power up testing for when you first power it up to make sure that the modules are programmed properly.
This video will demonstrate the power up test of these timer relay boards. First thing you do is turn the main power on. P1.1 will flash 3 times. We'll read 000s. And now we'll turn the receiver on. When we turn the receiver on, it will trigger all 4 of these modules. And they will all count up. And that's how you know it's working okay. Powered back off. Turn the receiver back off. And that's it.
To do operational testing of it after you've completed it, you want to hook up a test lamp. At least plug in one of the outlets. I check them one at a time, so I just swap the igniter leads from one to the other.
This is the wireless launch system I've been developing. It uses a DBR 1200 pad fireworks type launch controller. It controls 12 pads with 100 cells, or as it calls them, districts. That's the transmitter. This is the receiver, 4-channel receiver connected to these timer boards. The receiver doesn't put out much power, so it is used to trip these relay boards, which are programmed for 5 seconds. And it's plugged into the side here. There's the igniter leads. Here's continuity buttons. See that it's plugged in there. I have a test lamp as a stand-in for an igniter. And when I press the launch button, I'll press pad 1 over here. I'll give it a countdown. You will see the timer count up from 000 to 5.0, and you'll see the test light come on. So we'll go ahead and do that. 5, 4, 3, 2, 1. See, the lamp is on. That's counting up. Our continuity is good. There's a beeper inside the box. The other ones aren't connected, so there's no continuity there. These relay boards require a separate continuity circuit. These buttons are double throw, double pole. They're not standard push buttons, but they operate the same way. So when your rocket's hooked up, you just check continuity, and then you give a countdown. 5, 4, 3, 2, 1, and off we go. This uses a standard 12 volt 7 amp hour gel cell battery. The receivers are off the shelf item, as are the timer boards. And the push buttons, everything in this setup is an off-the-shelf type item. And thank you for watching.
All right, now we'll talk a little bit about sources for components for wireless launch systems. Can't just go in the store and buy this stuff, obviously. It's online. Some of the sources are Chinese. It can take a while to get the parts. You may never get the parts, but I've had pretty good luck with them. I do try to source things from stateside suppliers because it takes less time. I don't have to worry about them not being packaged properly. The relay modules, the switches, accessories, it's just a matter of using Google, eBay, Amazon, AliExpress, any of those types of things. You can just put in the right keywords. For example, 5 volt DC relay module, or fireworks firing system, or programmable timer delay. Whatever component you're looking for, just put that in and you should have a whole bunch of stuff to wade through. And you got to be careful because some of them are not really suitable for this use. Some of the components, especially the relay boards, sometimes they look like they'll work. I bought a few that I thought would work great and I couldn't get them to work. So that's why I stick to the ones that I'm used to that I know work. For the fireworks firing systems, there's an eBay store, Magic Effect. I think they're in China. They have a lot of stuff. And you can get the e-matches from them too. Pyro Boom is a US-based distributor. That's the one I've been getting the components for lately. The 4-channel receivers. And then the relay modules, again, AliExpress, Alibaba, or just the same thing, eBay, Amazon. They're might have to wait or just wade through them, make sure you've got the right type. So electronic components, that's a DigiKey. I get a lot of stuff from that firm. Most of these components are very inexpensive. Most expensive item would be the probably would just be the actual fireworks system. Here's the controller. Again, this would be a typical picture off of eBay listing showing the controller and different receiver types. The original ones just had a rocker switch for on and off. The newer ones, updated ones, actually have the proper switch that you turn on and off, removable switch. And then they have a rapid fire. This is like a sequence, and then they have all fire, which would be like a drag race. Some of the relay or some of the receivers have those functions switched off. I think if you get them from PyroBoom, you can request that they turn them on if you want to be able to drag race or sequential fire. Again, the Chinese manufacturer is of these the DVR system, but they are distributed domestically. They are FCC approved components, so you're not going to get in trouble for using some illegal wireless system. The DVR01 controller, that's the transmitter unit, at about $90 by itself, and you can either purchase receivers separately or as part of a package. So this would be like a set of 3 of the 4-channel receivers. That's about $40. If you got a whole setup with 6 4-cell receivers and a transmitter, it'd cost you about $120. Now to do the entire 24-pad setup, which would be like what you saw me build, that's a 4-pad thing. So it'd be like 6 of those, and the receiver and the batteries and everything could run you around $500, depending upon where you get your components from. If you buy them from a domestic distributor, they're usually a little more expensive, but again, you'll get them quicker and they seem to have a little better quality control. And there's not a whole lot of wireless launch system vendors out there designed for model rockets. Wilson FX is a popular one. They're a very good product, but they're very expensive. A comparable setup would run you around $2,400. So it's a big difference. This system is not nearly as fancy schmancy, but it definitely gets the job done. So here would be a typical eBay listing. What you'd see here is the transmitter box, and then 6 of the 4 cells. That would be a 24-cell setup. It'd be $120. And here's a standard module. It runs about $8, and it's basically very simple, straightforward relay system. They do have instructions online with these listings that tell you how to hook them up, and it's just good. So you're not totally in the dark on that. Again, it's just a search for DC 5-volt relay module. Probably get a dozen hits of that type of thing. Now here's a programmable solid state one. These only cost $5 a piece, which surprised me. I figured they would be more, but that's pretty reasonable. Again, these are simple to set up if you don't do the continuity circuit. And you're not required to have a continuity circuit, but most people do want ones. But you can do them without it if you want to keep it simple. And the P1.1 function is usually how they come from the factory. But if you have to reprogram it, just follow the instructions that it comes with, usually listed on the listing. So the nice thing about that module is that you can get it with a cover for a couple dollars more. And this is super simple to attach. You just use a couple of wood screws to hold it down onto those wooden dowels. Nothing sticks down below it. You don't have to worry about damaging anything. You just pop these little rubber grommets out, and then to access your terminal connections, you can make your connections and you put them back in place. And it's a nice, neat, tidy setup, and it works quite well. These are the programming buttons. So it's basically the exact same relay, it just has a cover. Troubleshooting, I'm not going to get into a whole lot of that. Most problems stem from bad or incorrect connections, corrosion issues, water exposure. You do want to check the terminal connections when you're putting it together and make sure they're tight, especially with these screw-in connectors, the terminals. Seems like it's going in there and you tighten it down and then the wire slips right out. So just give it a little pull to make sure it's tight. And like any other launch system, check your clips, the wire connections, make sure they're not corroded or burn up. And specifically inside a transmitter, take the cover off whenever you change the batteries. Take a look at it and make sure that there's no corrosion in there. If there is, just hit it with some contact cleaner and some emery paper. Clean it up. Get a good clean power. The other main source problems obviously is the low voltage from your discharged battery, so you kind of want to make sure you charge them and replace the AA's on a regular basis. Now the DVR controller receiver, they're not user serviceable, so if you have any problems with them, you're really not going to be able to fix them, and just replace them. You can try repairing but reconnecting the receiver with the transmitter. Sometimes they lose connection and you just have to reset that. So that's about it. I'll take some questions and comments. One person asked me was, would I be building these to sell? Right now, I'm not really planning on doing that. What I would consider doing, if the interest warrants it, would be to put together some builder kits, assemble the component, the relays, and the push buttons, all those components you need, rather than having to source them individually. I will consider looking into giving you or providing a package that you could obtain that would have all those components, and then you would have to put them together yourself. I'm not going to do all the hard part for you, but it's something I'm giving some thought to. So if that's something that people are interested in, I think in the near future, I'll kind of take a poll, or you can email me at roketrik@aol.com if you would be interested in something like that. Cost-wise, I'm not looking to make a lot of money on it. Basically, I'd just be acting as a go-between. So it would be a reasonable price for all that. I'm not going to gouge anybody. So I'll leave that open for questions and comments. Thanks for attending. In case you're wondering about what you see over my shoulder, those are original Estes, Mercury Redstone, Gemini Titan, and Saturn 1B, the original catalog offerings from the 1960s. And they're not fakes or clones. They're the real thing. All three of those have flown. And I've launched them off this very same type of wireless launch system. Thank you for watching.